In this section, we're going to be talking about groundwater, and groundwater is basically the most important kind of water for humans. We rely on groundwater so much. Groundwater is a major source of water for humans. We are pulling out the majority of our water is coming from in the ground. So groundwater is related to the water cycle because it accumulates in small amounts in the ground over time. And it goes underground in the water table and it comes out through springs or streams. And then eventually either we use it or it goes back into, say, rivers or oceans, or it evaporates into the atmosphere. A lot of the water that falls down as precipitation actually doesn't go and accumulate into a river or a stream. It actually just kind of percolates or infiltrates, goes back into the ground and becomes groundwater. Um, One of the things that's kind of odd about how we have chosen to build like our gutter system and everything is we don't want, like, when it rains for it to flood onto our house and property and things. And that makes a lot of good sense. But it does make it, by having cement, it makes it so that not as much water is able to percolate down as groundwater. And that's a bit of a problem that maybe will be solved at some point in the future. So how much water is able to get down depends on how much space there is between the ground. So if it's rocky, a lot can get through. If it's rocky with some sandy soil, less. And if the particles are really close together, then not much can get through. Um, it's important to talk about the water table. And let me get to a picture on that. So the water table is the depth of the water table is different depending on the conditions, which, let me move back up here. Depending on what kind of soil you have, or like if the land is sloped or not, is how deep your water table is going to be. In a stream valley, like, I want to go back up to this one. In a stream valley, the water table underneath, like if you were right here next to the stream and needed to dig a well, the water table is not very deep. It's maybe a few meters. But if you went all the way up here into the mountains to get to this water table, you would have to dig a much deeper well. In a place that's like a marsh or a swamp, the water actually can't go any lower, so you're actually at the water table. You're standing in the water table if you're standing in a marsh. Um, so underneath the ground, you can actually have these underground rivers, and the underground rivers are called aquifers. And it seems almost impossible. The way that they are formed is they actually have some kind of substrate, say like clay. So clay has been used anciently and it's used today to make things like pots. And if you have a clay pot at your home, you know you can pretty much put water in it and it does not come out. So when something like clay is lining the top and bottom of an underground river, the water can't go anywhere else except to move through this natural piping system. So it's basically makes this really cool underground river, and that's called an aquiclude. So it basically makes it to basically stop something. It's an aquiclude to stop the water from moving through. Um, Underground areas where water flows are called aquifers, and on both sides they're surrounded by an aquiclude, and that's usually clay so that nothing can get through. The speed at which this moves, I want to move down to this. Well, we'll talk about this in a second. The speed at which the water moves depends on the slope. So if it's very steep, then it will move very quickly. If it's not, then it'll move a little bit slower. So down here, sometimes these aquifers actually meet up with a mountain wall and will burst through it. So here's an aquifer that is literally bursting through this mountain. And that's actually got a cool name called a karst spring. So a karst spring is one that just pushes through and makes this spring, and it looks like, oh, where's that waterfall coming? It looks like it's coming in from inside the mountain, and it is. It's really cool. Springs will come out wherever the land here meets the water table. So you can see here there's land and here's the water table. And so along this line is where it would meet up. So these springs are coming out of it. So springs will happen, and down here you can see this is an aquiclude. So water can't keep going down. So it's going to burst through in these little springs. And here where it was meeting up right here, and there's the aquiclude, it kind of climbed up right here and came down here. So there's a few different pictures here about that. So sometimes these springs can actually be really hot. And if there's some kind of like volcanic activity or igneous activity that's like pushing and heating up the ground, it can actually make this water really hot to the point where it's boiling. And when it's boiling, it'll burst through, just like when you're cooking on the stove and you boil the water, it starts to push up and through because it expands. And then you have a geyser. And if you've ever been up to Yellowstone, you've probably seen some of these. Sometimes it's hotter, but it's not quite bursting through like a geyser, and that will be a hot spring. Usually these are not anywhere close to boiling. They're just warmer than other places. Going down to wells. Wells are really important. Some of you probably have a well, and a well is done by digging down into the ground and tapping into the water table. You can see that these three wells here are drawn at different heights, that each of these people had to dig a different depth of their well depending on where they were. Because the water is down here, there's nothing pushing it back up. There's no, mountain like this that's making gravity push it out. Because of that, in this kind of well, you are going to have to pump the water. You're going to need some kind of pump station. So that's what they're trying to draw here. Eventually, if you've pumped too much water out, then you can have what's called a drawdown, where this kind of gets filled in with dirt that gets sucked in from the sides, and everybody can lose their well. So it's important to keep our water table full. I'm curious if any of you guys have ever had that problem with your wells. So there's another kind of well that you don't have to pump, that makes a natural well, and the water comes out and will come up on your own. These are called an artesian well. An artesian well, here's the water in blue. Here is the impermeable layer, or the aquiclude. And here's another aquiclude, more groundwater. In this picture, you can see that the water is here, and then there's an aquiclude here. And because the water is up so high, it's going to push the water up the well without having to be pumped. And here you can see that the ground is lower, but it will still push the water up because the water line is higher. So this is called an artesian well, and these have been used anciently and they're used today. Why would it be important to have this impermeable layer or aquiclude at the bottom of, like, underneath this groundwater? Why would that be important to have an impermeable layer? Essentially, it makes it so your water stays in one place so that you know where that groundwater is going to be. It just makes it like a clay pot underneath. So an artesian well is good because it's pressurized and it's coming from an aquifer up above. So that's how an artesian well is working versus a well that you have to pump. This kind of well, because the water's not up higher, you have to pump it up. So that's how they are different. Okay, those are the main things that I wanted to talk to you about in this section. I hope you have a great day.